Today we are going to discuss very important topic, that is inverse trigonometric functions. Inverse trigonometric functions. That is inverse trigonometric. Inverse trigonometric functions. That is what? Inverse trigonometric functions. Before going to inverse trigonometric functions, already we know that function means if A and B are two non-empty sets, if A and B are two non-empty sets, that is, if A and B are two non-empty sets, that is, A and B are two non-empty sets, F is a relation from A to B, F is a relation from A to B, then F is said to be function if every element in set A, has associated with unique element in set B. Every element in set A associated with unique element in set B. That means every element in set A has unique F images in set B. Unique images in set B. Then only F is called what? Function. Function means A and B are any two non-empty sets. Then F is a relation from A to B. Then F is a relation from A to B. Then F is said to be function from A to B. If every element in set A associated with unique elements in set B. Every element in set A associated with unique element in set B. Every element, observe here, every element in set A. One associated with unique element in set A. 2 is also associated with unique elements in set B. 3 is also associated with unique elements in set B. And 4 is also associated with unique element in set B. So, F is a relation from A to B. Then F is function from A to B means every element in set A associated with the unique element in set B. Then F is called what? Function from A to B. That means it is denoted by F maps A to B. In that, A is called what? A is called domain. And B is called your codomain. A is called domain and B is called codomain. A is called domain and B is called codomain. This is domain. This is codomain. It is denoted by F maps A to B. This is a function F maps A to B. Here, actual images in codomain, that is A, B, P. The set of actual images, in the codomain is called the range of the function. Now, bisective function means a function is said to be bisect or bijection function. A function satisfies the 1 that is injection function and onto function. Onto means subjection function. That means a function has 1 and onto. That only the function is called bisective function. Bisective or bisection function. So 1 function means already we know that 1 function means every element that is in set A, different elements in set A have a different F images or different elements in set A associated with different element in set A. different elements in set A associated with the different element in set B, then F is said to be one function or injective function. Then onto function means if every element in codomain has at least one pre-image in set A. That means if the range of the codomain, if the range of the function is equal to its codomain, then the function is called onto function. If F is satisfied 1 and onto, then only F is called bisective function. Now, here inverse trigonometric functions. Inverse trigonometric function means, let us suppose already we know that F is A and B. If take A and B, any two non-empty sets, A and B, any two sets. If A and B, any two non-empty sets or any two sets. If A and B, any two sets, then is a F maps A to B. That is, F is function from A to B. Is a bijection. F maps A to B. Is a bijection. Then the function G maps A to B. This is domain, this is codomain. Then G maps B to A. Then G maps B to A. That means we interchange the domain and codomain. That is B map. G maps B to A. G maps B to A. Is the inverse of the function. Is the inverse of the function. Is the inverse of the function F. Is the inverse. So G maps B to A. Is the inverse of the function F. G maps B to A is called what? Inverse of the function F. Such that inverse of the function F. Such that F circle G is equal to, and it satisfies the condition. That is F circle such that F is a, this is called G maps B to A is called the inverse of the function. G maps B to A is called the inverse of the function F. So G circle F is equal to identity on A. G circle F is equal to G circle F is equal to identity on A, that is IA, and F circle G, that is composite function G circle F is equal to identity on A, IA, and F circle G is equal to identity on B, that is identity on B. This function, identity on B, this function G is, that means it satisfies G circle F is equal to identity on A and F circle G is equal to identity on B. That means this function G is unique. And it is denoted by F inverse. Observe that. Already we know that function and one function and onto function, bijection function already we discussed. So let A and B, if you take two sets A and B, any two sets, F maps A to B. F is function from A to B. F maps A to B is a bijection. Clearly, F maps A to B is a bijection function. Then the function, if you take the function G maps B to A, then take the function G maps B to A is the inverse of the function F. G maps B to A is called what? Inverse of the function F. G maps B to A is called what? Inverse of the function F, and such that it satisfies, that is composite function, that is G circle F is equal to identity on A. G circle F is equal to identity on A, and F circle G is equal to identity on B. identity on B, this type of functions exist unique. This type of function G is unique. It will satisfy G circle F is equals to identity on A, F circle is equals to identity on B. This type of function is unique. It is denoted by F inverse. That means F maps A to B, then F inverse is mapping from B to A. F inverse is mapping from B to A. That means we know that that bisective function only have the inverse function. If the function is bisective, then only it has inverse function. We know that all the trigonometric functions here in the chart is inverse trigonometric functions. We know that all the trigonometric functions are periodic functions. That means all the trigonometric functions repeated the values. After its period, the values are repeated. So all the trigonometric functions do not have inverse functions. Trigonometric functions do not have inverse function. Why? Because all the trigonometric functions not have bisective functions. If the function is bisective, then only it has inverse function. Otherwise the function do not have the inverse function. Clearly, all the trigonometric functions are periodic functions. So all the trigonometric functions are not a bisective functions, not a bijective functions. So it do not have any inverse function. But in the trigonometric functions, if domain, this is called domain, this is called codomain. If the domain of the trigonometric functions restrict or if the domain of the function is reduce or restrict, if the domain of the function restrict or reduce, then only the trigonometric functions are bijective functions. If the domain is adjusted some intervals, then only the functions are the bijective function. Then after that the trigonometric functions has inverse function. Otherwise trigonometric functions do not have inverse functions. If the domain is reduced, if the domain of the trigonometric functions reduce or restrict, then only all the trigonometric functions have the bijection. After bijection, the trigonometric functions have inverse functions. So let us discuss how to reduce the domain of the trigonometric functions. It will convert into bijective function. Let us discuss. Yes. Next, to reduce a trigonometric functions into bijective functions. To reduce trigonometric functions into bijection functions. To reduce trigonometric functions into bijective functions. Already we know that all the trigonometric functions are not a bisective function. That is not a bijection functions. But if your domain is reduced or restrict, then the trigonometric functions are bisective functions. Then only its inverse exists. Clearly, suppose we take the function. Let take the function. Take the function f maps from real number -1 to +1. F is mapping from real numbers to -1 to +1. If f is mapping from real numbers to -1 to +1, the function clearly f of x is equals to sin x for all x belongs to R. Let us take the functions f of x is equals to sin x. Clearly we know that the domain of the sin function is real numbers and the codomain is -1 to +1. Domain of the sin function is all the real numbers, but its range is -1 to +1. Observe here, clearly the sin function is not a bisecting function. Sin function not a bisecting. Not a bisecting. Why? Because it satisfies 1 and onto means it satisfies onto function but not 1 function. That means if the range of the codomain, if the range of the function is equals to its codomain, so range of the function. What is the sign range? Means clearly -1 to +1. So the range of the function is its codomain, so it is onto functions. But 1 function means different elements have different images, but here different elements have the same images. So the sin function is not a 1 function. That is not a injection function. So it is satisfied the subjection function onto functions. So not at all, it is a bisection function. That's why the sin function is not a bisection function. But if you restrict or if you reduce the domain, it is clearly the bisection function. We know that the graph of the sin axis, if you take the graph of the sin axis, this is clearly, this is 1, this is -1. Clearly, f of x is equals to sin x. F of x is equals to sin x. F of x is equals to sin x. This is the graph of the function. This is x-axis and this is y-axis. X-axis and y-axis. Clearly, this is 0. This is -5. This is +5. So this is the graph of the function sin x. The values of the sin function is, it will be repeated after the period 2π. Already we know that the sin function is a periodic function. The period of the sin function is 2π. So the values are repeated. So clearly this is not a 1 function. This is not a 1 function. This is not a 1 function. So it is onto function. So it is not at all satisfied the bisection function. If you restrict the domain or if you reduce the domain, clearly the sin function is a bisecting function. Then only its inverses exist. If the function is bisecting function, then only its inverses exist. Otherwise, not a inverse function. So how to reduce the domain means, if you take the domain clearly -π/2 to +π/2, -π/2 +π/2. If you take this graph, this is up to here, it will satisfy 1 and R2 also. That means up to -π/2 to +π/2. If you take -π/2 +π/2, clearly different elements inside here have the different affinities. If you take up here, this element and this element gives same affinities. So if you take here -π/2 to up to +π/2, it is clearly the function f of x equals sin x is a bisecting function. The function f of x equals sin x is a bisecting function. Then only its inverse exists. So the sine function is, the function sine is the function sine is mapping from, the sine function is mapping from minus pi by 2 to closed interval pi by 2 to minus 1 to plus 1 closed interval minus 1 to plus 1 is a bisective form. Clearly is a bisective form. Generally, the sine function domain is the range R, that is all the real numbers. Codomain is minus 1 to plus 1. So, if you restrict the domain or if you reduce the domain up to minus pi by 2 to plus pi by 2, minus pi by 2 to plus pi by 2 to my closed interval minus 1 to plus 1, then only the sine function is a bisective function. That is in the bisective form. The inverse of the function, the inverse exists. So, the inverse of the function, already we know that f is mapping from A to B, then f inverse is equal to what? F inverse is mapping from B to A. F inverse is mapping from B to A. Already we know that. F inverse is mapping from B to A. So, the inverse of the function is nothing but sine inverse, that is sine inverse is mapping from B to A. This is A to B. B to A means minus 1 to plus 1. Closed interval minus 1 to plus 1 to closed interval minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. Defined by sine inverse is equals to defined by sine inverse x is equals to theta. Defined by sine inverse x is equals to theta, that is implies and implied by sine theta is equals to x. Sine theta is equals to x. Sine theta is equals to x for every x is belongs to closed interval minus 1 to plus 1. For every x is belongs to closed interval minus 1 to plus 1. Is called the sine, is called the inverse sine function, is called the inverse sine function, or is called the inverse sine function, or the R sine function is called the R sine function. R is called the inverse sine function or the R sine function. Observe here. Already we know when the inverse function is exist means compulsory the function is a bisective function, then only its inverses exist. That means if f maps A to B is bisective, then only f inverse exists, that is f inverse is B to A. If f is a bisective function, then only its inverses exist, otherwise not at all exist. So, here we talk with these inverse trigonometric functions. Generally, the trigonometric functions are not a bisective functions. Why? Because the trigonometric functions are the periodic functions. After the period, the values of the trigonometric functions are repeated. So, all the trigonometric functions are not a bisective functions. So, that's why inverse is not exist. If we restrict the domain or we reduce the domain of the trigonometric functions, if you restrict the domain or the reduce of the domain of the trigonometric functions, then the functions are bisective functions. If you restrict the domain or if you reduce the domain, here observe here, let us take one example, then only it has the inverse function. Let us take one example here. If you take sine function, clearly the sine function of the domain is real numbers, all the real numbers. Range is closed interval minus 1 to plus 1. That is codomain. So all the real numbers. Domain is all the real numbers. Codomain is closed interval minus 1 to plus 1. In this situation, sine function, not a bisecting function. Not a bisecting function. Why means it is clearly onto function, not a one function. Why means the range of the function is its codomain. The range of the function, sine function also minus 1 to plus 1. So the range of the function is codomain. So sine function is a onto function but not one function. Why means the sine function's values are repeated. After period. One function means different elements in set A has different elements in set A associated with the different elements in set B. Then only f is said to be a one function. So here after period the sine function has the same values. So not a one function. So not a one function means it is not a bisecting function. If we restrict the domain, observe here the sine function graph is clearly this is the sine function graph. This is the sine function graph. After the values, observe here this value and this value same repeated, and this value is repeated same values. It will become same values. So that's why if you restrict the domain minus pi by 2 to plus pi by 2, take only this graph. That means minus pi by 2 to plus pi by 2. If you restrict the domain, if you reduce the domain up to minus pi by 2 plus pi by 2, closed interval minus pi by 2 plus pi by 2. Then range is also, the codomain is also minus 1 to plus 1. Then only the sine function has bisecting function. Then only the sine function is a bisection form. This is bisection form. Minus pi by 2, closed interval pi by 2 to minus 1 to plus 1. Then sine is a bisecting function. Then if it is bisection function, inverse is exist. If f is mapping from A to B, then f inverse is mapping from B to A. F is mapping from A to B. F is compulsory is a bisection function. Then f is mapping from A to B, then f inverse is mapping from B to A. So that's why the inverse function, sine inverse is mapping from closed interval minus 1 to plus 1 to closed interval minus pi by 2 to plus pi by 2. Minus pi by 2 plus pi by 2. So if you take any values of x is belongs to minus 1 to plus 1, there exists unique value theta is minus pi by 2 belongs to minus pi by 2 plus pi by 2. That is sine inverse x equals to theta. It is denoted by sine inverse x equals to theta is implied by sine theta is equals to x. Sine inverse x is equals to theta. That means x belongs to closed interval minus 1 to plus 1. There exists unique value of the theta is belongs to closed interval minus pi by 2 plus pi by 2. So then only the sine function is a inverse function. So this is called the inverse of the function, inverse of the sine function, or the arc sine function, the arc of the sine function, or the arc sine function, the arc sine function. That is sine function. Next, cos function also same. Second point. The function cos function is also domain is real number to codomain is minus 1 to plus 1. If you reduce the domain 0 to pi closed interval, that is cos function is closed interval 0 to pi to minus 1 to plus 1 is a bisective form. Then only it is satisfied the bisection function. So is a bisective form. Is a bisective function. Is a bisective function. If you reduce the domain, cos function is also domain is a real numbers. Codomain is clearly minus 1 to plus 1, closed interval minus 1 to plus 1. If you reduce the domain 0 to pi, closed interval 0 to pi, then only the cos function is bisective function. Then only the cos function is bisective function. The inverse function of f inverse cos inverse, that is cos inverse is exists from minus 1 to plus 1 to close interval 0 to pi. Close interval 0 to pi. Cos inverse is exists from minus 1 to plus 1. The domain is cos inverse function domain is close interval minus 1 to plus 1. Codomain is 0 to pi. That means if for every x belongs to minus 1 to plus 1, there exists unique value of theta belongs to closed interval 0 to pi. Closed interval 0 to pi. Then function is called what? The arc of the cosine function or the inverse of the cosine function. The inverse of the cosine function. That's defined by cos inverse x is equal to theta is implied by cos theta is equal to cos theta is equal to x. Cos inverse x is equal to theta is implied by cos theta equals to x for every cos theta is equal to x for every x belongs to minus 1 to plus 1 there exists for every x is belongs to minus 1 to plus 1. Minus 1 to plus 1. There exists unique value of the theta belongs to 0 to pi. Close interval 0 to pi. This function is called the inverse cosine function or the arc cosine function. The arc cosine function. That is, cos function is not a bisective function. If you reduce the domain, then the cos function is a bisective function. Then cos function is a bisective function. Then cos is 0 to pi to minus 1 close to minus 1 to plus 1 is a bisective function. Then cos inverse is b to a, that is minus 1 to plus 1 to 0 to close interval 0 to pi. That means if x belongs to minus 1 to plus 1, there exists unique value of theta, that is which is lies between 0 to pi. Then this type of function is called what? Inverse cosine function. Inverse cosine function or the arc cosine function. Inverse cosine function or arc cosine function. Next, third one. That is the tangent function. So the function tan open interval minus pi by 2 to plus pi by 2. The function tan is mapping from minus pi by 2 to plus pi by 2 to minus infinity to plus infinity. Minus infinity to plus infinity is a bisective form or is a bisective function. Then its inverse also exists, that is tan inverse minus infinity to plus infinity to minus pi by 2 plus pi by 2 is called the inverse trigonometric, that is inverse tangent function. Inverse tangent function or the arc tangent function is a bisective function. The inverse function tan inverse is mapping from minus infinity to plus infinity over interval to minus pi by 2 to plus pi by minus pi by 2 plus pi by 2 is defined by tan inverse x is equal to theta is implied by tan theta is equal to x for every tan theta is equal to x for every x belongs to minus infinity to x belongs to minus infinity to plus infinity. X belongs to minus infinity to plus infinity is called the inverse tangent function. Or the arc tangent function. clearly tan function is also not a bisexual function. If you reduce the domain, if you restrict the domain, minus pi by 2 plus pi by 2 to minus infinity to plus infinity. If you restrict the domain, if you reduce the domain, it is clearly bisective function. It inverse exists, that is tan inverse minus infinity to plus infinity to minus pi by 2 plus pi by 2. If the x belongs to minus infinity to plus infinity, there exists value of theta, that is minus pi by 2 plus pi by 2, then this function is called what? Inverse tangent function, or the arc tangent function. The arc tangent function. Next, fourth one. If the function cot is closed open interval 0 to pi to minus infinity plus infinity. The function that is clearly cot function is mapping from, if you restrict the domain up to open interval 0 to pi to minus infinity to plus infinity. Minus infinity to plus infinity is a bisective function. Then only is a bisective function. The function is a bisective function. The inverse function. The inverse. Then only inverse exists. Cot function is not a bisective function. If you restrict the domain, if you reduce the domain, that is open interval 0 to pi. Then codomain is clearly minus infinity to plus infinity. Codomain is minus infinity to plus infinity. The inverse function, that is denoted by cot inverse is mapping from minus infinity plus infinity to open interval to clearly 0 to pi. Clearly 0 to pi is called that means every belongs, that is every theta, every axis belongs to minus infinity plus infinity. There exists unique value of theta is like between 0 to pi. Then the function is called what? The inverse cotangent of the function, the arc of the cotangent of the function. 0 to pi is called defined by cot inverse x is equal to theta is implies and implied by cot theta is equal to x, cot theta is equal to x for every x belongs to minus infinity to plus infinity. Is called inverse cotangent function. Is called inverse cotangent function. Is called inverse cotangent function, or the arc cotangent function. The arc cotangent function. This is function. Next point. The fifth point. The function secant. That is secant function. The function secant is mapping from closed interval 0 to pi by 2 union pi by 2 to pi. Secant is mapping from closed interval 0 to pi by 2 open interval union pi by 2 to pi is closed interval. 0 to pi by 2 open interval union open interval pi by 2 to pi 2. This is domain. Then the domain is restricted. The secant function is also not a bisective function. If the domain is reduced, if the domain is restricted up to, that is secant is 0 to pi by 2 close interval 0 to pi by 2 open interval union open interval pi by 2 to close interval pi 2 minus infinity open interval minus infinity to minus 1 minus infinity to minus 1 close interval union close interval 1 to infinity close interval 1 to infinity is called is a bisective function. Is a bisective function. Clearly, secant function is not a bisective function. If the domain is restricted, if the domain is restricted up to 0 to close interval 0 to pi by 2, union pi by 2 to pi close interval to this domain is restricted, then the secant function is clearly bisective function. Secant function is clearly bisective function. The inverse function clearly, that is secant inverse is mapping from f is mapping from a to b, then f inverse is mapping from b to a. B to a means clearly minus infinity to minus 1 close interval union close interval 1 to infinity open interval, that is 1 to infinity 2 that is b to a, that is close interval 0 to pi by 2 union pi by 2 to close interval pi, defined by secant inverse x is equals to theta. Secant inverse x is equals to theta implies and implied by secant theta is equals to x. Secant theta is equals to x for every x belongs to, x is belongs to, that is minus infinity to minus 1 union 1 to infinity. X is belongs to minus infinity to minus 1 union 1 to infinity close interval. There exists unique value of theta, that is close interval 0 to pi by 2 union pi by 2 to pi is called the inverse secant function. Is called the what? Inverse secant function is called the inverse secant function or inverse secant function or the arc secant function. The arc secant function. So secant function is not a bisective function. If you reduce the domain or if you restrict the domain 0 to close interval 0 to pi by 2 union pi by 2 to close interval pi, then only the secant function is a bisective function. After bisective function, secant function is after inverse function is exist. That is, if f is mapping from a to b is a function, then f is a bisective function. F inverse is clearly b to a. That is f inverse is b to a. So that is secant inverse x is equals to theta is implies and implied by secant theta is equals to x. For every x is belongs to minus infinity to minus 1 close interval union to close interval 1 to infinity, there exists unique value of theta. So this function is called what? Inverse secant function or the arc secant function. Next, the function, next one, sixth one, the function cosecant is mapping from the function. Cosecant function is not a bisective function. The cosecant function is not a bisective function. If you restrict the domain minus pi by 2 close interval minus pi by 2 to 0 union minus pi by 2 to 0 union 0 to close interval plus pi by 2 0 to close interval plus pi by 2. This is if you restrict the domain close interval minus pi by 2 to 0 union open interval 0 to pi by 2 close interval, that is 2 minus infinity to, that is minus infinity to minus 1 union 1 to infinity minus 1 to minus infinity to minus 1, sorry, minus 1 to infinity to plus 1, union minus infinity to plus 1, union 1 to infinity. 1 to infinity is a bisective function, is a bisective function, is a bisective, is a bisective function, is a bisective function, clearly is a bisective function, is a bisective function. The inverse function, the inverse function, the inverse function, that is cosecant inverse, cosecant inverse, cosecant inverse is mapping from, that is cosecant inverse is mapping from, so this is minus 1, clearly minus 1, that is cosecant inverse is mapping from minus infinity to minus 1 closed interval, union closed interval 1 to infinity, 1 to infinity, 2 closed interval minus pi by 2 to comma 0, union 0 to pi by 2, 0 to pi by 2 is defined by cosecant inverse x is equal to theta is implicit implied by cosecant theta is equal to x for every x is belongs to minus infinity to minus 1 union 1 to infinity. There exists unique value of theta. Is called inverse cosecant function. Inverse cosecant function or the odd cosecant function. The odd cosecant function. Secant function and cosecant function, not a bisective function. If you restrict the domain, the functions are the bisective function, then only its inverse or exists. Its inverses exist. Here the functions are called inverse secant function. Here the function is called inverse cosecant function. Next, let us discuss some properties of the inverse trigonometric functions. Yes. Now, domain and ranges of the inverse trigonometric functions. Domain and ranges of the inverse trigonometric functions. Domain and ranges of the inverse trigonometric functions. Already we discussed in previous the facts. Already we discussed 6 points. That facts, if you reduce the table, easily understood by observing how to draw the table means, that is inverse trigonometric functions. Inverse trigonometric function. Inverse trigonometric function and domain, that is domain, and that is range. First one, if you take y is equals to sine inverse of x, already we discussed this. Y is equals to sine inverse of x. Clearly, this domain is closed interval minus 1 to plus 1. Already we discussed. Y is equals to sine inverse x. If you take the inverse trigonometric function, that is sine inverse x. The domain is closed interval minus 1 to plus 1. Range is clearly closed interval minus pi by 2 comma plus pi by 2. This is the range. If you take second function, that is y is equals to cos inverse of x. Y is equals to cos inverse x. Domain is clearly minus 1 to plus 1. Range is clearly 0 to 5. Already been discussed this. If you take y is equals to dot function, y is equals to tan inverse of x. Tan inverse of x. Tan inverse of x. Domain is all the real numbers. Domain is all the real numbers. Range is open interval. Range is clearly open interval minus 5 by 2 comma 5 by 2. Minus 5 by 2 comma 5 by 2. That is. If you take y is equals to cot inverse x. Y is equals to cot inverse x. Cot inverse x range domain is clearly all the real numbers. Cot inverse x domain is all the real numbers. Range is close open interval 0 to 5. Open interval 0 to 5. If you take fifth one, y is equals to cosecant inverse x. Y is equals to cosecant inverse x. Clearly domain is minus infinity to close interval minus 1 union 1 to infinity. Close interval 1 to infinity. Clearly its range is close interval 0 to pi. Close interval 0 to pi. Close interval 0 to pi. Union or close interval, sorry, this is close interval 0 to pi. Union pi to, that is union 0 to pi. Union 0 to cosecant. We want cosecant minus pi by 2. We want what? That is cos x is equals to y is equals to cot inverse x. That is inverse trigonometric cot inverse x. Domain is real numbers and range is clearly open interval 0 to 1. If you take fifth one, y is equals to cosecant inverse x. Y is equals to cosecant inverse x. Clearly its domain is minus infinity to minus 1 union close interval 1 to infinity, and the range is clearly close interval minus 5 by 2 comma 0 union 0 to 5 by 2 close interval. This is. And if you take sixth one, y is equals to secant inverse x. Y is equals to secant inverse x. Clearly domain is minus infinity to minus 1 union 1 to infinity, and the range is clearly 0 to close interval 0 to pi by 2 union pi by 2 to pi. Above all the given facts, if you write them on table, that is domain and ranges of the inverse trigonometric functions. Clearly here, inverse trigonometric functions, domain and the range. Inverse trigonometric function, domain and the range. Already we discussed. If you restrict the domain, then only the function is bisecting function. After that, its inverse is exists. So, inverse trigonometric functions, if you take y is equals to sin inverse x. Y is equals to sin inverse x. Domain is minus 1 to plus 1. Domain is minus 1 to plus 1. Its range is clearly close interval minus pi by 2. Close interval pi by 2. Domain is close interval minus 1 comma plus 1. Close interval minus 1 comma plus 1 is the domain. And the range is close interval minus pi by 2 comma pi by 2 close interval. Take second function y is equals to cos inverse x. Y is equals to cos inverse x. Inverse trigonometric function, that is cos inverse x. Clearly domain is minus close interval minus 1 to plus 1. Domain is close interval minus 1 to plus 1, and the range is clearly close interval 0 to pi. Close interval 0 to pi. Next, sorry, this is 0 to pi. If you take the trigonometric function y is equals to tan inverse x. Y is equals to tan inverse x. Clearly, domain is all the real numbers, and the range is clearly minus pi by 2 to plus pi by 2. Open interval minus pi by 2 to plus pi by 2. If you take y is equals to cot inverse x. Y is equals to cot inverse x. Domain is real numbers, and the range is close interval 0 to pi. And the range is close interval 0 to pi. If you take y is equals to cosecant inverse x. Cosecant inverse x. Domain is minus infinity to minus 1 close interval union close interval 1 to infinity. Then the range is close interval minus pi by 2 comma 0 union 0 to pi by 2. That is the range of the cosecant inverse of the function. And if you take y is equals to secant inverse x. secant inverse x. The domain is clearly minus infinity to minus 1 union, 1 to close interval 1 to infinity, and the range is clearly 0 to close interval 0 to pi by 2 union, open interval pi by 2 to pi, that is close. That is the range of the secant function, secant inverse function, secant inverse function. This is the term. Next.